derive the equations of motion. So in today's agenda, we are going to derive equations of motion. Lot of students might know there are three equations of motion that we study in kinematics, and we will look at how to derive that. Because when I ask students how the derivation of these equations come, they get stuck a lot of times. So whether you are in 11th or in 12th or in drop year, this derivation is very important, because this is not just about kinematics derivation. This is about the attitude towards derivation. We want to develop the attitude towards derivation. In the previous activity, we showed you the attitude towards animation. So that attitude we are building in this master class, and that's why this master class is different from the other classes, because here we build the right kind of attitude. So what are the equations of motion? So what are the equations of motion? V is equal to u plus at. That's the first equation of motion. S equal to ut plus half at square. That's the second equation of motion. And v square equal to u square plus 2as. So we will look at how to derive these equations. Lot of students might already know this, but let's derive it once more so that you develop attitude towards derivation. So let's call this equation 1. So v is equal to u plus at, we are calling this equation 1, and s equal to ut plus half at square, we are calling this as equation 2. Okay, and v square equal to u square plus 2as, we are calling this as equation 3. So let's start with the derivation of v equal to u plus at. V equal to u plus at. So we know that acceleration is equal to dv upon dt. We know that acceleration is equal to dv upon dt. So how to derive equation 1? So what we do, we take dt this side, and we integrate both sides. So one point to note is that these equations of motion are only valid when acceleration is constant. So these equations are only valid when acceleration is constant. If acceleration is not constant, we cannot use these equations, and these equations are not valid. So please everyone note that these equations are only valid when acceleration is constant. So when acceleration is constant, we will take it outside the integration and we will put the limits. So at t is equal to 0, velocity is u, which is the initial velocity, and at time t, velocity is v. Okay, so what we will do, we will take a outside the integration, and integration dt comes out to be t. Integration of dt comes out to be t from 0 to t. Here we are putting the limits. Integration of dv comes out to be v, and the limits are 0 u to v. Okay, so once you will put these limits, you will get v minus u is equal to at. So that's the derivation of the first equation, v minus u is equal to at. Okay, so hope you have understood this, and hope you are making notes. So please keep making notes, because here we are developing the attitude towards derivation. If you will not derive the concepts yourself, you will always make mistakes in problem solving. Okay, now how to derive s equal to ut plus half at square. S equal to ut plus half at square. So how to derive this? We know that ds upon dt is v. So v is equal to ds upon dt. We know this. And from the previous equation, we found that v was u plus at. V was u plus at. That's what we found in the previous equation. So integration of ds comes out to be integration of u plus at into dt. Integration of u plus at into dt. Now let's put the limit. At t is equal to 0, displacement is 0. At t is equal to t, displacement is s. Okay, so once we will put the limits, we will find that s minus 0 comes out to be u into dt. Here u is initial speed, which is considered to be constant. So this is constant, u is constant. Okay, u is constant, and acceleration is also constant. So we will take these outside the integration. Okay, so u into integration of dt, that means u into t from 0 to t, and a into integration of t dt. Integration of t dt is t square by 2 from 0 to t, from 0 to t. So s equal to ut plus half at square. That's what we got. So equation 2 also we got derived. We derived the equation 2 as well. So now we will be deriving the third equation, which is v square equal to u square plus 2as. So how to derive this? So let's observe closely. In this equation, time is not there as a variable. So what we will do from equation 1, we will find the value of time, and in equation 2 we will put that time, and hopefully we should get equation 3. Okay, so from equation 1, we should get time as v minus u upon a. Okay, so from equation 1 we are getting time as v minus u upon a, and then we are putting this time in s equal to ut plus half at square. So please everyone start doing it with me. Please put that. So please put t is equal to v minus u upon a in s equal to ut plus half at square. Let's see what we are getting. So s comes out to be u into t, which is v minus u upon a. Plus half into a into t square. So t square comes out to be v minus u upon a whole square. Okay, so u into v minus u upon a plus half a into v minus u upon a whole square. So let's simplify this. So s equal to, in denominator we will have 2a, and then it would be 2u v minus u plus v minus u whole square. Okay, 2u v minus u plus v minus u whole square. So s comes out to be v square minus u square upon 2a. So that's how this third equation is derived. So again, what we are developing here, we are developing the attitude towards derivation. Whether you know this or not, it doesn't matter. But from now onwards, start deriving each and every formula that you encounter in physics or maths or chemistry. If you're not doing that, the problem solving skills won't be that good. Okay, so start using the animations, start using the derivations. Okay.